Okay, let's see. Hey, let me just talk through part D here. A line forms whenever A of t is greater than or equal to 400. The number of vehicles between A and 4 is given by n of t. N of t is the integral of A of x minus 400, where A is the time when the line begins to form. To the nearest whole number, find the greatest number of vehicles in line at the toll plaza. So basically, I have to find that greatest number of vehicles. That's the indication. Okay, we have to apply extreme value theorem. We're going to find critical points. We're going to find endpoints. And then once we find our critical points and endpoints, we can plug them all into n of t and see which one produces the largest value. We're looking for the most number of cars. So I know I can find critical points by setting n prime equal to 0. So to find n prime, I'm going to find the derivative of this integral here, which is second theorem. So second theorem allows me to get it all the way down to A of t minus 400. I set that equal to 0, so I'm just going to graph this A of t minus 400 and look for my x-intercept. So this is what I did for my window here. I did x min x max 500, negative 500, just because my coefficient was all the way in the hundreds. For x min x max, I knew that I was going from some value after 0. So I didn't have to go, I didn't have to do negative 5. I can just go from 0 to 5 here. Now, we're looking to see where the line begins to form. So line begins to form whenever A of t minus 400 or A of t minus 400 is equal to 0. So it's going to be this x-intercept. So this x-intercept is a critical point, but it's also going to be our endpoint. It's also going to be where the problem starts. That's our A value. So we're going to do second 0, find that x-intercept, second trace 0, find that x-intercept. And so they end up being 1.469 and 3.598. So because 1.469 also acts as an endpoint, we'll test that. And 4 and 3.598. They all go into the n of t equation that's given to us. And then we can just plug that in and compare values. 71 will be the largest, and that will occur at 3.598 hours. Okay, number 2. Oh, sorry, we're doing 1, 5, and 6 now. So let's go to page 13. Okay, this is non-calculator, so let's keep that in mind as we work on number 5. Page 13. do you know what A is? Well, this is A of t minus 400, and it says whenever the line begins to form. So line begins to form whenever A of t is greater than 400. So basically wherever A of t is equal to 400. Is A of t minus, that's my A of t minus 400. Okay. Yeah. I see.
They might also say the revenue as a lease. I bond, so you create. And 3.598 can also be a. Yeah, but that's only considered how they build. That's just given by this.
That's where the line begins to form, but then they give you the endpoint of 4. So we want to use 4 as the endpoint. So technically it's 2 x-intercepts and an endpoint. And it just so happens that this x-intercept is where the line begins to form. So that also acts as our starting point.
Oh.
Page 13, area for part A is just top minus bottom. We work that out by hand. Part B, volume by cross section. We know the area is xe to the x over 5. So we're trying to find the integral of x times e to the x over 5 from 1 to 5. This is a e substitution is not going to work. So our next option is the integration by parts. So going through tab method to get it all the way down to just the numeric answer. And this is not a calculator, so you don't have to even clean up the answer as far as I got. You can leave it in this form, and this would give you full credit as well. I just reduced it because I saw things that canceled out, but you didn't have to go. You don't have to clean anything up, but not calculator.
If extreme value theorem, it has to be continuous. Like you have to state that.
Yeah, we should be stating that. Let's see.
BT, via state.
Yeah, we should be stating differentiable and continuous. Yeah, but EVT, we should have to be stating continuous. I think I. Now, yeah, for. Yeah, Rolle's theorem and mean value theorem is the only one where the requirement is differentiable.
Instead of y, does that mean that the function doesn't have an absolute like maximum, or like an absolute maximum can't be guaranteed?
Yeah, so if I don't have a continuous function, if I don't have if the function is not continuous between the endpoints, including the endpoints, then I can't guarantee an absolute max or absolute min, because there could be a sudden hole where that max was supposed to be. But typically, with these problems, if they're trying to get you to use EVT, they're going to have the conditions set up for you. It's not going to be like a tricky thing where, oh, there's a hole there, you can't apply EVT. That's very rare. Yeah. Part C, find the volume of the solid generated whenever the region W is revolved around the x-axis. If you're revolving about the x-axis, there's no gaps between that and the x-axis, so we know that this is going to be this method. However, it's unbounded, so the fact that it's unbounded is going to we're going to do some improper integral here from 3 to infinity, so we got to work it out by hand and show that it's either unbounded, diverging, or converging volume.
Yeah. Not something like question 3, but also in general, if you're doing EBT and you know that some points just aren't going to be what you're looking for, will you still get credit for EBT even if you don't test every single critical point?
Yeah, you don't test every single critical point. If it's only asking for absolute minimum and then there's a relative max as a critical point, you don't have to test the relative max. Yeah. Just have to test your endpoints and your relative minimum, relative max, depending on what they're asking.
What if it's like, if you have a start point, interval of decreasing, and then an area of increasing? Well, then can you like just test that middle point? Like, so no, only be that middle point?
Yes, you can, but you have to maybe state something like, because the function is always decreasing to the left and always increasing to the right, my absolute minimum must be this point. Yeah, we have to state something to let the grader know that you are using the behavior of the graph to help you make that conclusion. Okay, any questions with number 5? So we go through this method, work it through, and we see that our B is in the denominator, which is going to allow for that clean 0 to show up. And 0 plus pi over 81 is a conversion value, so my volume is pi over 81. If you're good with page 13, go to page 14.
So one BC topic FRQ.
You mean for number 5? Or for?
Or actually, was part of 5 BC? Like, was this a BC one? Or?
Yes, this is a BC one, yeah. So parts B and C are BC topics because iteration by parts is BC and then the proper interval is BC. And if you're good with page 13, go to page 14. Just have to keep reminding ourselves that whenever we see a series problem, we just have to put away our calculators and just do everything without a calculator.
Let's see. Was 14 of those. But wait, 6 points. The calendar? Yeah, yeah, I think it's 14. Six. How long do we have to do these 6 FRQ problems?
You mean on the AP exam? You're averaging 15 minutes. Well, they give you an average 15 minutes per problem.
So they give you like 30 minutes with the calculator and 60 minutes without.
Right,
You can
okay.
go back without the calculator.
Right, so what's gonna happen is when you get your FRQ exam, you're only gonna be able to see the first 2 questions, the first 30 minutes. So first 30 minutes, you're not gonna be able to see numbers 3 through 6. It will just be 1 and 2. But after 30 minutes, you gotta put your calculator away. You can unseal numbers 3 through 6, and then you can work on 3 through 6 after 30 minutes. But you can go back and work on 1 and 2, but just without a calculator. So you'll be given an hour and a half. So then after 30 minutes, you'll be given another hour. And that hour you can divide up however way you want to work on any of the problems 1 through 6. But the first 30 minutes, you're only going to be able to see 1 and 2.
Did you just like suggest doing all the calculator tasks as quickly as possible?
Yeah, so if you can't finish 1 and 2 within 30 minutes, at least try to do all the parts that require a calculator, because you can always go back and work on 1 and 2 just without a calculator after 30 minutes.
You still like get some points, right? Like you can.
Right, it depends on how they define partial credit. Right, so. But yes, the graders are always looking for ways to give students partial credit. At page 14, number 6, questions there. Okay, if you're good with page 14, then go back and finish off the rest of your 2022 FRQs. Yeah, let's keep working for another 5 minutes.
For my work, for finding like the area.
You don't have to, no. No, answer your work.
Do you have to show your work on, like on the series problem for testing your one and negative one?
You don't have to show your work, no. Mm-mm.
I can't be like sure.
What, the radius?
Yeah, like I don't know, like it's called for like. Do they
Oh,
always
so-
get a whole number?
Yeah, so I would look at the radius here. I would look at radius from here to here. That's gonna be 2.
Oh, that makes sense.
Yeah, based on the center.
For the question on future routine, why wouldn't you need to do like an equation? No, I was just asking for what you said.
Yeah, that was a little bit strange. And that's a weird one in terms of the area here. So.
Everything might be.
RFR. One five five. This is like a really strange Riemann sums here. Like this, I remember when we saw this, we're like this is so strange. Now, imagine if that wasn't there, right? We're used to that. That feels easy, right? Then it's just, width times height or width times height, width times height. But the fact that they're doing R f of R, we're gonna have to also include the R value at the height where we're finding that height value. So we have to be able to pull the 1 to 2, the 2 to 6. So not only are we trying to find the height, we're also plugging using the R value for that height, which is really strange. Like that's just like we never see that before. So yeah.
So just figure out, like, move the R to the 2.5.
Or understand that R f of R is part of the calculation for your height.
Okay,
Yeah. So weird.
That's just excellent.
Already pretty modern. It's small, whereas the air already less than that. Because you could also prove by using the first 2 elements available to finding this area as being called, but you can do it. All you're doing is showing the best of it. It's less than. Whatever you're using. Second term, it's less than that.
Okay, tomorrow I'm going to be checking the 2022 FRQs. I printed out packet 6, so if you want to pick that up today, you can. So you come get your phones, and then I have packet 6 and the key ready if you like to have that.
So. If you that compare.
Steph, you're saying,
Is this one?
Is this one calculated? The one that
Yes, yeah, this one, the one that you're working on, that's a number 1. So that's the calculator one. Yeah, that's fine. Good.
does it matter if I say, graph changes between increasing or decreasing? Because I just said the graph, slope of the graph changes sign.
Yeah, the only thing is don't use the word graph, like name that function you're talking about. Like if it's f prime, we have graph of f, right? If you just say graph it, they may take off point because it's too vague.
Yeah.
Yeah, but that's fine, that's fine. I'm still waiting for students to check, so hopefully it's Friday.
Oh, great, thank you. It's spread out though.
I have 6 a.m.
I have a question.
Shines,
Drive, sometimes drive.
Yeah, I mean, it's fine.
To go to the school. Huh? Yes. But. Yeah, it's like.
Okay, so understand that this is an alternate series like so whenever you see this notation, that means find the difference between f of 1/2 and 1/2. So whenever you see this notation like this, it's basically always asking about. So we know that for alternating series, the way you find the remainder is to find the difference. So then because of that, first unused term.
Because like science, you get a serious,
That's right, like, because it's only, right, yeah, understanding that this is the approximation, working free approximation, which means that the first unused term, you gotta use the free, or the next term. The next term is, yeah, it's this executable free. So this tells us how off this approximation is to the actual f of 1/2.
And then when you plug it into that, also like 1/2 is 1/8.
Yeah. Over 3. Right, but it's always absolute value. So the error bound is always the absolute value. So we're always going to consider just a positive number, positive version. Because, this 1/24.
Yeah, the data.
If the error is 1/24 positive is less than, or 1/24 positive is more than, we just care about the error. So the error is 1/24, which is clearly less than 1/2.
Wait, oh, then, it was
Okay, so f of 1/2 is the actual value of the function. The actual value of the function would be adding infinite terms from x all the way to x to infinity. That's the actual value. But we know that the x minus the x is the approximation. That's just an approximation. If you have a finite number, that's just an approximation. Actually,
So why do we think that F we want?
because
I can feel it.
The,
I know that the next term has to be less than one. For the area, less than, for the remainder to be less than one. But why does the F of 1/2 is less than? Next term?
okay, so are you in agreement that F of 1/2, whatever F of 1/2 is,
I'm gonna be in a.
that 1/2 is an approximation of the actual value of F of 1/2? Are you agreeing?
Yeah.
Okay, so we know this is approximation. And then so what we have to do is we have to figure out how accurate is this compared to actual unknown value. So then we want to find some accuracy for approximation. We should have to look at the first unknown. That's nice. The nice thing is the first unknown term tells us how accurate we are. The worst case scenario, how accurate we are compared to the actual. This is one term for, like, we're one term closer, that one term closer. Tells us now, if
That next term is less than 1.
that's right. So if this,
And it's like, oh my God, what did you hear?
yeah, so we know that our answer is going to be here. We should show that this number is less than 1.
That, and like, it has.
That this approximation is off by no more than it's less than. So our accuracy is better than 1/10. Our accuracy is at worst 1.4.
It's so.
You know, the same.
No, I'm not absorbing, I'm mostly trying. It's pretty hard to absorb information.
I don't know this is
Yeah.
not gonna be put in growth.
I hate it for.
But you know what?
Like,